In the next couple of videos, we're going to look at how we can decide the ion charges of elements based on their electron configurations and also on their periodic table locations, which of course are determined by the electron configurations, as we learned in the previous chapter. So we use the periodic table to find ion charges of just some of the elements. We call these the representative elements because they behave in the way we hope they will. They represent what we expect to happen. It does not work for the transition elements, that is all the stuff across the middle in the depressed section, or for the stuff at the bottom, the rare earths. We have to have something else for that. So we're going to broaden our knowledge of what goes into making ions, but let's just review what we know so far. If we're in group number 1, or just the first group on the periodic table, the alkali metals, let's harken back to those days when we used the periodic table for this. You may even have the periodic table that we made in the first semester. And we figured out that those things, or we learned then anyway, that those things are +1 ions. That's going to show up over here as the second column. If we're in group 2, the Roman numeral 2, or this second one on the chart, that's the alkaline earth metals, then those things are +2. If we jump across the transition section to the group 3 or number 13, for a couple of those things are +3. But then we jump over to group 5, and we learned that those things are going to be -3, group 6 -2, group 7 or 17, we're just numbering them, the new system, -1. So here those things are all I just said. So we just basically memorized that, or we wrote it down on a periodic table. But now let's have a look at why that's the case. So we're going to learn perhaps the most important rule in all of chemistry. It's called the octet rule. The octet rule says that most elements are more stable when they have 8 valence electrons. Remember, valence are the ones in the outermost energy level. So that would be a filled outer energy level. After you get 8 electrons, you would then do the overlap, and you would have something else occur in the next shell. So it's called the octet rule because if you have 8 valence electrons, things are more stable, and in nature, things want to be more stable. The noble gases already have 8 valence electrons, with the exception of helium, which we'll talk about later. So they are already stable. They tend to not react with anything because they're already stable. So everything on the periodic table is going to strive to be stable. We don't want to try to give it human characteristics, but everything wants stability. And so everything wants to be like a noble gas. I'm going to make some kind of analogy here. The noble gases are like the nobility, and everything wants to be like the nobility. It's just a silly analogy, but one that works pretty well. Okay, so what we'll do then is we'll start looking at different groups of elements now, starting with the metals in the next video, and see what's going to happen with their electrons and the octet rule.